Welcome to today's discussion. Today we are going to look at a question on the extraction of metals, but specifically we are going to look at the extraction of copper metal. But before we look at this particular question, if you have just come across this channel for the first time, kindly take 1 second and click the subscribe button. Remember, copper metal is a metal that is extracted using a reduction method. And under reduction method, we use reducing agents. But in this case, we are not going to use reducing agents here. We are going to do what we call self-reduction process. Remember, the whole procedure of extraction of metals takes about 4 steps. And the first step is where we do the mining of the ore. After mining the ore, we concentrate the ore by a process known as flotation. This is where the crushed ore is mixed with water and oil. Water sinks heavy impurities, mainly silica, and floats the ore, which is the chief ore we use to extract copper metal. After concentration of the ore, we do what we call reduction of the metal oxide, and lastly we do purification, since these metals have some impurities. In this case now, before we look at the whole process in this particular flowchart, we are going to start by looking at the chief ore for the extraction of this particular metal, which is copper. So we are going to begin with the metal itself, and the metal here we are going to extract is copper, and the copper is extracted using reduction, since it is a metal which lies in the middle of the reactive series. The first thing that happens, or the first step, is where the ore is concentrated by a process known as flotation. But before we look at the first step, we need to know the chief ore for the extraction of copper metal, and the chief ore for the extraction of copper metal is copper pyrites, which is CuFeS2. So the first step is where the ore is crushed, then concentrated by the flotation. After the concentration of the ore, we take the concentrated ore and roast it in air, that is in limited amount of air. That is, we are going to have copper pyrite. This is a rock. We roast it in limited amount of air, and this roasting of copper pyrite will give us a copper 1 sulfide, which is a solid. It will give us sulfur 4 oxide gas, and lastly we have iron 2 oxide, which is a solid, or we can call it the impurity in the concentrated ore. Sulfur 4 oxide of course escapes, or it is tapped and used in contact process. We remain with copper 1 sulfide and iron 2 oxide. Once sulfur 4 oxide has been tapped off, we remain with copper 1 sulfide and iron 2 oxide. From there now, we add silica, which is the main impurity in soil, and the silica is to separate or remove iron 2 oxide, which gets out as slag. So the second step is where we introduce silica, and the silica will combine with iron 2 oxide to give us what we call iron 2 silicate, which is commonly known as slag. We have already discussed some of the uses of slag in our previous discussions. Once we get rid of iron 2 oxide as our impurity in this particular ore, we are going to remain with copper 1 sulfide. The copper 1 sulfide that remains after we have removed iron 2 oxide is again roasted in controlled amount of air, and this one converts it into copper 1 oxide plus, of course, sulfur 4 oxide gas. We can balance this equation. We can balance the equation by writing 2 behind copper 1, then we write 2 behind sulfur 4 oxide, and of course 2 behind copper 1 sulfide. Remember, when we are roasting copper 1 sulfide in controlled amount of air, not all of it is converted into copper 1 oxide. So the unconverted copper 1 sulfide will reduce the copper 1 oxide into copper metal, which is a solid, and of course sulfur 4 oxide gas. In this case, now we can balance our equation by writing 6 behind copper. We write 2 behind copper 1 oxide, and the equation automatically balances. In this case, we have copper, but the copper we have obtained is impure, and therefore we call it blister copper. And blister copper is made pure by carrying out what we call electrolysis. The diagram we use to purify copper metal will look like this. We are going to have the impure copper as the anode, and the pure copper as the cathode. This is the impure copper being used as the anode, and this is pure copper electrode as our cathode. What happens when the current is flowing? The impure part of this blister copper will simply dissolve and get into the solution, and the pure copper will get deposited at the cathode as the pure copper. From there, the impure part will be deposited below the anode as large impurities, and in this case we could have now purified our copper metal. But we have two important reactions that take place. One, we have a point where the anode dissolves so that it can release the pure part of the copper and the impurities. In this case, the copper metal, which is a solid, will dissolve and get into solution as copper 2 ions, and it will do that by releasing 2 electrons. And at one point we will have the cathode where the pure copper is deposited. So the copper 2 ions in solution will gain 2 electrons so that they get deposited at the cathode as the pure copper metal. So having looked at that, let us now go through our flowchart and look at the expected observations and answers. The question we have reads, study the flowchart below and use it to answer the questions that follow. We have the copper pyrite, which is the chief ore for the extraction of copper metal, where it is crushed and mixed with water and oil together with compressed air, and what is coming out is the silicates. And remember, the main silicate here is iron 2 silicate. We are also going to have calcium silicate. Then the concentrated ore comes to the first roasting furnace, where it is reacted with controlled amount of air to give us copper 1 sulfide. We have sulfur 4 oxide gas and iron 2 oxide. Here we are going to have iron 2 oxide. We have copper 1 sulfide. We also have sulfur 4 oxide from the first roasting furnace. Then we go to the smelting furnace, where silica is added, and we have already said at this particular point iron 2 oxide will react with silica to form iron 2 silicate, which is slag. Then from there we go to the second roasting furnace, where we are going to have copper 1 sulfide. And remember, here we are going to have copper 1 sulfide being reacted with air to give us copper 1 oxide plus of course sulfur 4 oxide gas. Copper 1 oxide reacts with an converted copper 1 sulfide to give us copper metal. Then copper metal is purified to give us pure copper metal. Lastly, we have the uses of copper, that is making electrical cables, making of coins, making of soldering wires. So let us go through the questions and see what the questions are requiring us to do. A, name the ore being used in the flowchart. Remember, we use the chief ore, which is the copper pyrites. That is CuFeS2. Part B, how surface area of the ore is increased. We increase the surface area for the extraction of copper metal by crushing the ore. By crushing the ore. We move down to part C. Which process occurs at the mixing chamber? The process that occurs at the mixing chamber is concentration of the ore by what we call froth flotation. Next, we have D. In D says, explain the use of the following. We have water. The reason why we are adding water, actually, water sinks the earthly impurities and helps to float the ore. So the purpose of adding water is water sinks earthly impurities, mainly silica, and floats the ore. The two are separated. Then of course the ore goes into the first roasting furnace, where it is heated to give us copper 1 sulfide. iron 2 oxide and sulfur 4 oxide gas. Then we have silicon 4 oxide. The reason why we introduce silicon 4 oxide, it is to remove impurities, or we can say to separate copper 1 sulfide and iron 2 oxide from the first roasting furnace. But how does that happen? Let us look at part E. Write an equation for the formation of slag. Slag is formed as a result of the reaction between iron 2 oxide and silica, which is silicon 4 oxide, and this one gives us, that is FeSiO3, which is iron 2 silicate or slag. The next question we have, write down the equation for, we have already done that. F, identify the cations present where the metal is being purified. The cations present in this case are copper 2 ions. We go to G, give a reason for the following uses of the above metal. The above metal is copper. We give a reason why copper is used for making electrical cables, and the reason here is because copper is a good conductor of electricity. Copper is a good conductor of electricity. We have making coins. We use copper to make coins because copper does not rust. Materials that rust cannot be used to make coins. Question number 7, which is out of copper, but under the extraction of metals, reads, remember to subscribe to the channel and also help us to share the link. Name the chief ores used in the extraction of the following. Zinc is extracted from zinc blender, and zinc blender is simply zinc sulfide. Aluminium is extracted from bauxite, and bauxite is hydrated aluminium oxide. We have lead metal, which is extracted from the chief ore known as galena, and galena is simply lead sulfide. Then sodium is extracted from rock salt, that is sodium chloride. That brings us to the end of this particular discussion. Thank you for watching, and welcome to this particular lesson or channel. And in case you are coming across this channel for the first time, kindly take 1 second and click the subscribe button so that anytime we do a video like this, you'll automatically be notified.